Hello, today we're going to talk about bringing everything together that we've talked about this unit so far and actually graphing, but we're going to be using a Desmos in this case, but you can use any graphing utility that you want. So before we start talking about that, the one last piece that we haven't discussed are max and mins. And so we have two types of maximum and minimum. So we have an absolute max and minimum, which is listed here at the bottom, which is similar to what you have seen as a maximum or a minimum previously. And that is what is the point that contains the largest y value or the smallest y value. A relative maximum or minimum is something that is going to be a turning point like we've discussed before. And it's going to turn from either from increase to decrease, and that would be a relative maximum, and then from decrease to increase would be a relative minimum. And so the Desmos gives these relatively easily, so we're going to show you how we get those, and then you're going to transfer that information onto a graph. So if we're looking at this equation right here, what we want to do is we want to type this into Desmos and see what that gives us. So if we plug that in, then we should get something that looks like this, which should make sense. We should be able to see that we have a 0 at -1 with a multiplicity of 2, so that's going to be a bounce. And then we should also see that we have these points here are all things that we can use to make sure that we get an accurate graph. And so when we transfer this back over, we should get our zeros are at -1 and 3. Our domain is going to be all real numbers. And then our range was going to range from our value of 0 all the way to positive infinity. And we're going to include 0. And then we said we had x-intercepts at -1, 0, and 3, 0. And then we had a y-intercept we found was at 0, 9. You could also find that by plugging in 0 in for x and then solving for there. Okay, if we go back to that, we know that this is a fourth degree polynomial, but we did have three turning points. So we had this turning point, this one, and this one. So those are also called extrema. And so we would say that we just have 3 extrema, depending on what they ask. And then our end behavior was, as we go to the left, our function is going up. And as we go to the right, our function is still going up. And that's true because it's a fourth degree polynomial. So all you have to do is just graph your points. So we're at -1 and 3. So those were our zeros. We should have a point here at 9. And then I would make another one at 16. And so we have a point here at 0, 9. And we have a point here at 116. If you're doing it not on an actual graph, you might want to just label that as 116 just so we're aware. We're coming down from here. We hit that point, we bounce back up, we go through here, we hit that as our relative max. We come back down, and then we bounce back up. So we'll have a graph that looks something like this, in which you need to include all of those points, turning points, x-intercepts, and y-intercepts. If we look at the next one, so we have something that's not in factored form, so we have to be able to graph this. We should know it's a positive leading coefficient on a cubic function, and we should know that we have a y-intercept at 0, 4. So if we go to graph this, again, we want to type it in and making sure that we have something that looks like a cubic with a positive leading coefficient. And so we can find all of these points, and Desmos does a very good job of finding all these points and using them as you don't have to do a whole lot of information to work through it. And so we do need to take all of those off. I'm going to round that maximum, to the relative maximum, to 2 decimal places. And so we're going to convert that back over. And so we had zeros at -0.5 and 2. And then our range, again, for all these polynomials are going to be all real numbers. Our range, though, is going to be all real numbers for this one since it is a cubic. And then we said we had x-intercepts at -0.5, 0. And 2, 0. And then our y-intercept we said was at 0, 4, which you can find algebraically or from the graph. And then we had this area here, this point right here is our relative min because we go from decrease to increase. So we have a relative min at 2, 0. And then we have a relative max when we go from increase to decrease. And like I said, I'm going to round that to 2 decimal places. So we're going to say 0.33, comma 4.63. And then our absolute min, we should know it goes all the way down to negative infinity. So we're going to say none. And same for absolute max. And that's going to be true for all odd-powered functions. So transferring that information over. So we have a point here and here. We have a at 4. And then we had this point right here, which I would label since it's not at a whole number point. So I would just say that this is at 0.33, 4.63. And then we are going to come from down here. We're going to cross. We're going to go through that y-intercept. We're going to come back down, and then we're going to bounce. And so we have a graph that looks like that. Lastly, we have x to the 4th minus 6x squared plus 9. So again, we should know that this is a 4th degree that opens up. So they're both going to open up. So if we are both end behaviors are going to go up. So if we look to graph this, we just always want to confirm that just so if there was an error typing it in. And we have these 3 turning points that also happen to be our zeros. So again, I'm going to round that to 2 decimal places to negative 1.73 and 1.73. So we have zeros at negative 1.73 and 1.73. Our domain for all these, like I said, is all real numbers. Our range in this case goes from 0 to positive infinity. And then we had x-intercepts at negative 1.73 comma 0. So you want to be careful with your notation, and 1.73 comma 0. So that's the difference between a 0 and an x-intercept. And then we had our y-intercept at 0.9, which also those values, the x-intercepts happen to be relative minimums and also absolute minimums, and the y-intercept actually was a relative maximum. So our number of extrema, if we go back to that, is we have those 3 points. So we have that, that, and that. Those are all relative mins and maxes or turning points. And so we would have 3 of those, which aligns with our rule, saying that we could have at most 3 in a quartic polynomial. And then our end behavior, they're both going up. So as we go to the left, we're going up. As we go to the right, we are going up as well. So again, we just want to transfer this information over. So we have 1, negative 2, and we have a point roughly there, and then at 9, we had another point right there. So again, I would just make sure that you understand that that's negative 1.73 comma 0, and that is 1.73 comma 0 as we're trying to transfer this over. And we're going to come back down, we're going to bounce, we're going to come back up. That's our max, relative max. We're going to turn back down, we're going to bounce, and we're going to come back up to look something like that. And so to point out, these two would be absolute mins because that's as far down on the graph as we go. So they are absolute minimums as well as relative minimums because you do go from decrease to increase. Whereas the 0.09 would be an absolute, or would be a relative maximum, but not an absolute maximum. So I hope this helps you in being able to use Desmos to be able to graph polynomials and find some of the characteristics.